Types of functions. There are mainly three types of functions: one-one or injective functions, onto or surjective functions, and one-one and onto or bijective functions. Let's discuss these functions in detail. One-one function. A function f in which a changes to b is said to be 1-1 if each element in a has distinctive image in b, that is, for all x1, x2 belonging to a, such that f of x1 is equal to f of x2, which implies x1 is equal to x2. The one-one functions are also called injective functions. For example, the given function is one-to-one function, as there are distinct images in B for every element in A. Here, the images of P, Q, R, S are 4, 2, 1, 5 respectively. Onto function. A function f in which A changes to B is said to be onto if and only if every element of B is the image of some element of A. All elements of B are used. For example, the given function is onto function as for every element of A, there exists an image in B. Here the images of P, Q, R, S are 4, 2, 2, 5 respectively. The onto functions are also called as surjective functions. One-one and onto function. A function f in which A changes to B is said to be 1-1 and onto if it is both 1-1 and onto. The 1-1 and onto functions together are also called as bijective functions. For example, the given function is a bijective function as it has the characteristics of both injective and surjective functions. Here the images of P, Q, R, S are 4, 2, 1, 5 respectively. Composition of functions. The composition of the functions is defined as applying one function to the results of another function. If a function f in which a changes to b and function h in which b changes to c, then composition of f and h, which is denoted by h-o-f, is a function from a to c. Finally, we can write h of f of x is equal to h of f of x for all x belonging to A. For example, in the given example, x is fed as an input on which function f acts, and the output of f of x is fed to the input on which the function g acts, which finally gives us g of f of x. Example 2. Show that g o f is not equal to f o g, where f of x is cos x and g of x is 3x square. Solution. We have f of x is cos x and g of x is 3x square. So g o f of x is equal to g o f of x, which is equal to g of cos x equal to 3 cos x whole square equal to 3 cos square x. Similarly, f o g of x is equal to f o g of x is equal to f of 3x square equal to cos 3x square. Note that 3 cos x square is not equal to cos 3x square for x equal to 0. Hence, GOF is not equal to FOG. Invertible function. A function f in which x changes to y is invertible if and only if there exists a function h in which y changes to x such that FOG is equal to Ly and GOF is equal to Lx, where Ix, Iy are identity functions. So h is called inverse of function f and is given by f inverse. For example, here we have the function f of x equal to 2x plus 1 written in a flow diagram. Fed x as input to A multiplying by 2 machine, we get 2x. It is then fed to adding 1 machine, which gives 2x plus 1. Consider an inverse function y, and it goes the other way, as y is fed to A subtract 1 machine, which gives y minus 1, which is fed to a divide by 2 machine, which gives y minus 1 by 2. So, the inverse of function 2x plus 1 is y minus 1 by 2.